So today we are going to solve this problem, Backspace String Compare 844. So in this problem we are given two strings S and T. So these strings contain lowercase letters and a special character like hash. Okay, now the important thing is the hash symbol represent a backspace. That means whenever we see hash we must delete the character before it, just like pressing backspace on a keyboard. So what is the goal? So the task is process both string, apply the backspace operation whenever we see hash appears, and after processing both string completely, check if the final result are equal or not. If both final strings are equal, return true. If they are different, return false. Let's understand with an example. If we have yes is equal to a b hash and c, and t is equal to a d hash c. Now let's process string s. Okay, now see, a first is a, so result become a. Second is b, so result become a b, and third one is hash. Okay, so this delete b. Okay, third one is hash, so this delete b, so now it becomes a only. And fourth one is c, so result become a c. So final result of yes is a and c. Now let's process string t. So a, so result become a. Next is d, so result become d, a and d. Okay, and third one is hash symbol, so delete d, so now it's become a, so we delete d, so it's become only a. So fourth one is c, so it's become a and c. Final result of t is also a c. Okay, both final strings are equal. Okay, ac, the answer is true. Okay, so the answer is true. Now let's take another example. If we have yes is a b hash hash and t is equal to c hash d hash, let's first process s. A becomes a, now with b, a b, so the result become a b. Now third one is hash, so we delete b and it's just become a. So fourth one is hash, so we delete a. Okay, we delete a, so it was an empty string. So final result of yes is empty, nothing is there. Okay, we have did everything. Now we process t. So first is c, so the result becomes c. Second one is hash, so we delete c. Okay, so we delete c, so strings become empty. So third one is d, so result become d. So fourth one is hash, so we delete d, so a string become empty. So the final yes strings also empty and t string also empty, so the final answer is true because both are empty. Okay, let's take another example. S is equal to a hash c and t is equal to b. Okay, first we process s, a, result become a. Next is hash, so result become empty, we delete a. Third one is c, result becomes c, so the final result is c. Okay, final result is c. Next we process t, so b, so result become b. So now c is not equal to b. Okay, so c is not equal to b. So the answer is false. Okay, so see, whenever we see hash, we remove the previous character. Okay, we remove the previous character, and after processing both string completely, we simply compare them. Okay, we just simply compare them. That's it. No, see, we can solve this by using stack. I can build the final string and compare. That works, but it use extra space. Instead of building the string, can we compare characters directly without creating new string? So yes, we can do that. Okay, see, mm, so in this problem I will build final string using stack. Okay, using stack, using stack, last in first out, I think, first in last out, first in, something like this only. Stack full form. We can solve this by using stack as well. We can solve by stack w for stack LIFO, I think LIFO, yes, last in first out. Last in first out, that's work, but we can do better. So backspace hash always delete the character before it. So if we look from left to right, we cannot know the future, so we don't know the future. But if we look right to left, things become easier. Why? Because if we see a hash, we just remember I need to skip one character instead of building new string. Okay, we just skip characters. So the idea is we use two pointer. Okay, start from end of the both string and move backward and keep a counter. If we see hash, we increase counter. If counter is greater than 0, we skip character. Okay, so we never build string, we just compare valid character directly. So let's understand clearly. We have string like a, b, hash c, and t string is a, d, hash c, 0 1 2 3 0 1 2 3. It was index. Okay, we use two pointer j and I. We start from backward. I is equal to 3 and j is equal to 3. Okay, so string of I c and t of j is c. S of I is c and t of j is c. They match, so we move left. Okay, I j, so they both match, so we move to left. J comes here. Next, so I is equal, now I is, wait, I is 3, j is 3, so we move left. Now I become 2, j become 2. Okay, so S of I is hash and t of j also hash. Okay, that means we need to skip one character. Okay, so we take count of yes, count of yes. Okay, 1. So I minus we do. Now I is equal to 1. I is equal to 1. We will have right. I is equal to 1. So what is this? S of I is b. Okay, so count of s is 1, so we skip this character. Okay, so we skip this character. Count of s we do minus I minus Okay, we skip this character. Next I comes 0 becomes 0, so s of I is 0, so the character is a. Okay, no more skip, so the valid character is a. Do at same to t also. Okay, t also has to count. We take one more count of t. Okay, so the count is 1 become 1, count become 1. Now we do j minus minus, so j becomes 1, j also becomes 1, so the 1 the value, so the character is d. J of t of j, the character is d. Skip, so we skip it, count minus minus, we do count minus minus, and j minus minus, so j becomes 0, so the valid character is a. Now, so we compare now s of I a, so t of j a, so it both match, so we both move left, so -1 because it's out of 1, so we are going to return 1. Okay, we have 1 means true. One means 2. So let's write down the code. See, because we start comparing the right side, so first we need I and j, so let's write, we need 2 pointers, that was I and j is equal to s dot size -1 means start from last. Okay, int j is equal to t dot size -1 means start from last, because we need to comparing from right side. Okay, now we create skip counter also. In COU into count, yes means for yes, and in counts t 0 or t. Okay, to count how many characters we must skip. Okay, next loop until both string finish, while I is greater than or equal to 0 or j is greater than or equal to 0. So why we have used or means because even if one string finish, we still need to check the another. Okay, next, while I is greater than or equal to 0, if string of I is equal to hash, string of I is equal to hash COUNT count of years plus place and I minus minus, else if count of yes is less greater than 0, count of years minus minus I minus minus, else break. Okay, so in this what happening, if hash increase skip, if skip is greater than 0, skip that character, so else stop valid character was founded. Okay, next same process we have to do with t also. fill j, while j is greater than or equal to 0. If t of j is equal to hash count t plus plus j minus minus, else if count of t is greater than 0, decrease count count t minus minus and j minus minus, else break just break. Ouch. First we have compare ij count, while row we have start with counter I, else if the count find I have tried this out of wait. See back. J if I is greater than or equal to 0 and j is greater than or equal to 0, if s of I is not equal to t of j, so return false. Okay, else if I is greater than or equal to 0 or j is greater than or equal to 0, return false. Next we have to I minus minus and j minus minus, next I just return true row. Something is wrong. Okay. If we did this, break j minus if we increase counter, just a second. bracket mistake, it's very confusing to me. 1 2 3 else if we start this bracket and we have rows. Okay, I have write rows next to while. Yes. Yes, see. Now let's understand here. If we have yes is equal to b x j hash hash t w, okay, and t is equal to b x o hash j hash hash t w. So see, now first we understand the rows again, okay. Normal, let us keep them. If we see hash, delete the previous one, previous character. We are solving using two pointer from end idea, okay. We move right to rev, we skip character when we see hash, okay. It was clear now. So 0 1 2 3 4 5 6 0 1 2 3 4 5 6 7 8. So I is equal to 6 and j is equal to 8. So s of I and t of j, that was w. So then match, so we move j I comes here and j comes here, okay. Now it's 5, it's 7. So see, s of I it was t and t of j it was t, so it was matched. So we move left, j comes here and I comes here, 4 6. So now see, hash has came, means skip one character, so we create a skip counter, okay. For yes, see, for yes we count yes is equal to 1, we move left, so I comes here. So s of 3 is hash only, so again, so count become 2, so we move to I comes here. So s of 2 is now j, but we skip so 1, so we must skip one character, so we cut 1, so s of count of s become 1, so I comes here, okay. So we have to skip s is equal to 1, and so we skip again, so it's become 0, so I comes here 0, so s of I of 0 is b, okay. So we skip yes is valid, so we found, so for yes is valid character is b. So next we process to t, so we are at index 6 now, okay. So it was hash, so we create count of t is equal to 1, so j comes here, so it was again hash, so count becomes 2, so j comes here at 4, okay. So we skip this character count, so count become 1, so j's come here, okay, again, so the count become 2, so we move left, so we skip 8, so the count become 1. So we move J, so the count become 0. Okay, so J comes here, so the left character last is B, yes and T. So C for yes B, and for T it was B, so they match. So we move left, so it of out of bound -1, so we found it, so the answer is true. Okay, after applying all hash operation, we find yes become B T W. Final result of T also become B T W, so they are equal. So in this, what did we learn? We never build a new string. Okay, we just move forward right to left whenever we saw a hash. Okay, increase skip count and skip character, compare only value data. Okay, so that's it, and let me submit this.